Question. One projectile moving with a velocity v in space gets burst into two parts of masses in the ratio 1:3. The smaller part becomes stationary. What is the velocity of the other part? Okay, let us assume a body of mass m initially move with a velocity v so that it has a momentum p equal to mv. And suddenly it is exploded into two parts. It is exploded into two parts having masses in the ratio 1:3. So masses split in the ratio 1:3. So one mass is m by 4 and second mass is 3 m by 4. So they have masses in the ratio 1:3. And the smaller part becomes stationary. Smaller part becomes stationary means the momentum is m by 4 into 0. The speed of smaller part is 0. And plus, we don't know what's the speed of the larger part. Let us denote it by v naught. V naught is the speed of larger part. So this is the total momentum before explosion and this is the total momentum after explosion. So equating mv equals 3 by 4 mv naught. So m get cancelled. You get velocity of larger part as 4 by 3 into v. So third option is the correct option. This is the next question. A stationary bomb explodes into two parts of masses 3 kg and 1 kg. The total kinetic energy of the two parts after explosion is 2400 joule. The kinetic energy of smaller part. A body is exploded. A stationary body is exploded into two parts having masses 1 kg and 3 kg and they move in opposite direction. And it is given that the total kinetic energy is 2400 joule. Total kinetic energy of the sum of the kinetic energy of both parts is 2400 joule. And here we have to find the kinetic energy of smaller part. Smaller part is 1 kg. We have to find the kinetic energy of the smaller part. So smaller kinetic energy of smaller part is denoted by E1. E1 equal to m2 divided by m1 plus m2 into total kinetic energy. Total kinetic energy is already given and m2 is 3 divided by m1 plus m2 is the total mass, that is 1 plus 3 into total kinetic energy is 2400. So that's equal to 3 by 4 into 2400. That is, the answer is 1800 joule. The kinetic energy of lighter part is 1800 joule. Therefore, the option 2, second option is the correct option. This is the next question. A mass of 100 gram strikes the wall with a speed 5 meters per second at an angle as shown in figure. It rebounds with the same speed. If the contact time is 2 into 10 raised to minus 3 seconds, what's the force applied on the mass by the wall? And here on the wall, a ball strike and its rebound. And from the figure, we get this angle is 60 degree. So the angle made by the velocity with the normal to the wall, this is the normal to the wall. An angle made by the velocity with the normal to the wall is 30 degree. Both angles are 30 degree. If the angle made by the velocity with the normal to the wall is 30 degree, the force exerted by the wall on the ball is 2 mu cos theta by t. And that's equal to 2 into mass is actually 100 gram. So 100 gram is equal to 0.1 kilogram. 100 gram is 0.1 kilogram. So I write here 0.1 into velocity is 5 into cos theta, cos 30. 30 degree is the required angle. Cos 30 is root 3 by 2 divided by total time is 2 into 10 raised to minus 3. Cutting 2 and 2, 10 raised to minus 3 go up. So you get 0.5 by 2 root 3 into 10 raised to 3. So solving you get 250 root 3. And there are two options, option 1 and option 3, but the answer is 250 root 3. The question is the force exerted force exerted on the mass by the wall. The wall exerts a force on the ball towards left. So third option is the correct option. This is the next question. 3 interacting particles of masses 1 kilogram, 2 kilogram, and then 4 kilogram. There are 3 masses, 4 kilogram. Moving with velocity 1 meter per second, magnitude along the positive direction of x, y, and z axis respectively. So three particles are moving with equal velocity. Velocity of all the particles are equal. They are 1 meter per second. So first particle has mass 1 kilogram. Its velocity is 1 meter per second. So its momentum is 1 into 1, 1. And the direction is along x direction. So the momentum is 1 I cap or I cap. And second particle has mass 2 kilogram, velocity 1 meter per second. So 2 into 1 is 2, momentum is 2 unit. So it's 2 j cap because the particle is moving along y axis. Third particle has mass 4 kilogram, velocity 1 meter per second. So 4 into 1 equal to 1. So 4 into 1 equal to 4. So the particle is moving along z direction. So it has momentum 4 k cap. And this is the total momentum. Equals total momentum after the interaction. Due to force of interaction, something happens here. So the first particle has momentum m1 v1, second particle has momentum m2 v2, and third particle has momentum m3 v3. In the question is given that the third particle stops. Since the third particle stops, the momentum of the third particle becomes 0. So I delete that term. Momentum of the third particle is 0. And here the velocity of second particle is given as 2j plus k in the question. So velocity of second particle, I replace v2 by 2j cap plus k. It's given. And the mass of second particle is 4 kilogram. So I replace 4 here. And mass of the first particle is 1 kilogram. So replacing 1 here. Okay. So now you have to find out V1. So vector V1 equals to I plus 2j plus 4k minus 4 into 2j plus k. So you get I cap plus 2j cap plus 4k cap minus 8j cap minus 4k cap. Simplifying, you get I cap 2j and 2 into 4, 8j cap. Here the mass of the second particle is 2 kilogram actually. There is a mistake, 2 kilogram. So let us make a correction here. It's 2 kilogram. So 2 into 2, 4j cap. It's 4j cap. And plus 2k cap minus 2k cap. So I cap 2j minus 4j, you get minus 2j. 4k minus 2k, you get plus 2k. So second option is the correct option.